In this video, you'll learn how to balance chemical reactions. They tend to be a little bit tricky at first, but if you practice them, they get easier as you go. So if you take the time to practice, they get easier and easier. If you just kind of refuse to do them, then they're going to continue to be a struggle. So make sure you're taking the time to struggle at first, work through those struggles, and I promise they will get better. Now, the first thing I got here is the steps. I actually don't really like to follow the steps too much. I'll show you my way. I'll give you the steps because they can be helpful. The first one definitely is very useful. Use a pencil because you're going to end up erasing. You never get it. Okay, I shouldn't say that. Never. You very, very commonly you will have to go back and change answers, and it's not because you got it wrong the first time. It's because as more information comes up, you have to go back and fix past attempts, I guess you should say. And I'll show you an example of that right away when we do some examples. Balance the metals first tends to be a pretty useful tip. Then the polyatomics next. Then you balance all the non-metals that aren't CH or O. Then you balance the CH and O in that order. And then remember to have fun because this is chemistry, but please don't spend a ton of time memorizing these rules. I don't think it's worth your time. Do some practice problems and then go back and check these if you'd like to, but I would say just do some practice problems and you could probably ignore these rules and be just fine. But extra hints, these are actually quite useful. Always use whole numbers. You need to use the smallest ratio. So if you come up with a set of coefficients that can be reduced, or simplified, you need to simplify them. Indicate the state of the compound or element. This isn't actually useful for balancing yet. This will come in handy when we predict products and do solubility. Remember diatomic molecules. Again, those will actually come in handy more when we do predicting products. But if I'm looking at my first example here, you'll remember this slide actually you might remember this slide from the last video. We've got our reactants on this side, we've got our products on this side, and remember when we balance, the whole idea is that we have to satisfy the law of conservation of mass. The atoms that go in must equal the atoms that come out. Now if I count these up here, I've got one carbon on this side, one carbon on this side. And you can see the one black carbon and the one black carbon. Great, that works. But here I've got 4 hydrogens and only 2 hydrogens. Well, you might be like, well, let's just make this H4O, and then we've got everything solved. But you can't do that. This is H2O. This is water. We know that in this compound we observed that water is formed. If I change this to H4O, that's not water. I can't just go ahead and change formulas. So when you balance equations, you can only change coefficients in the front and say how many waters. I can't change the fact that it's water, but I can change the fact that there might be more than one water formed in this reaction. The next thing you might notice is that there's 3 oxygen. There's 3 red ones, 1, 2, 3 on this side. There's only 1, 2 on this side. So to start solving these problems, I'm going to put a 2 here. And what that means is that there's 2 of these oxygens. There's 2 of them. I didn't change the fact that it's O2. It's still O2. It's just now there's 2 of those O2s. The next thing is I'm going to put a 2 in front of the water. And then that means there's 2 waters. Now if you count everything up, there's still 1 carbon on each side. There's 1, 2, 3, 4 oxygens here, 1, 2, 3, 4 here, and there's 4 hydrogens and 4 hydrogens. So everything works out now. And I did that fast. I didn't want you to, or I didn't expect you to necessarily follow that, how to put the coefficients in. But what I want you to understand from this slide is that you can't change the fact that this is water. But what you can change is the fact that there's 2 of them. That's a legal move to make when you're balancing equations. You can put in this 2 up front here. We call this a coefficient. Coefficient. It tells me how many waters are formed. I'm not changing what is formed, I'm just changing how many. So let's do a practice here. So let's get into the actual practice here. I always like when I balance these is to put a wall here. And I say what's on this side has to equal what's on this side. Now there's different ways people like to do it. I'll do it the long way to start with. You can continue to do it this way if you'd like, or you can drop the extra work here if you want. It's up to you. One way that some people like to do it is they like to list, okay, there's an aluminum and there's oxygen, all the elements. And they say, okay, there's 1 aluminum and 2 oxygens on this side. There's 2 aluminum and 3 oxygen on this side. Well, we've got a problem because these numbers don't equal, and the rule of the law of conservation of mass says they need to equal. So the problem here is that, okay, I've got a 2. To get this to be a 2, I'm going to double it. To double it, I have to put a 2 up here. Now you cannot put a 2 right there. Absolutely not. You cannot change the formulas. You can only put coefficients in front of the whole formula. Now the next thing, this is 3. So I've got 3 oxygen and 2 oxygen. To get them to equal, I'm probably going to want to multiply this one by 3 and this one by 2. This one by 2. Now that gets me 6 oxygen and 6 oxygen. But when I put this 2 here, that means there's 2 of this whole thing. So now there's 6 oxygen and there's times 2, there's 4 aluminum. Well, I need to go back then and change this 2 to a 4 to get that to equal. So this 2 becomes a 4. And that's why I recommend using a pencil so that you can erase. Because it's not that you made a mistake when you put a 2 here. It's just that you realize after you put a 2 here that you have to go back and change it. So if you're doing this in pen, it's going to get messy, kind of like mine is, because it's kind of a pain to go back and erase with this pen thing that I have. So now if you double check, there's 4 aluminum, 6 oxygen on this side. There's 4 aluminum and 6 oxygen on this side. This is a balanced chemical equation. Now let's try the next one. Now you can continue to write out everything here. If you want, you can put aluminum. Now keep the polyatomics together. Don't count this as S and O separately. Count it as an SO4. Then I go Ca and then OH. And then you do the same thing on this side. You better have the exact same ones too. Aluminum, SO4, Ca, and OH over here. I'm not going to do it that way. I'm going to show you the other way. And this is how I like to do it. I'm actually going to start clean here. What I like to do is I just like to look, okay, I like to point at the same element on each side. Aluminum. There's 2 on this side. There's 1 on this side. Okay, that doesn't work. So let's fix it. So let's put a 2 here. We got to double it. Now let's just look at the metals first. I'm going to look at calcium on this side, calcium on this side. There's 1 of each. It's not broken, so there's no need to fix it. There's already equal numbers. Let's check the next thing. SO4 on each side. Okay, the parentheses with a 3 means that there's 3 on this side. There's no parentheses here, so that means there's only 1 of them. A common mistake is people think that there's 4 SO4s here, but there is only 1. Because it's a polyatomic without parentheses, that means there's only 1 of them. Now, if this is 3 and this is 1, well, I better multiply this by 3. But that becomes a problem because now I have 3 calcium, and I only have 1 last time, so I better go put a 3 here. So all I'm doing is I'm finding things that are broken and I'm fixing them. And let's just double check. 3 times 2 OHs gets me 6. 2 times 3 of them is 6 OHs. So the OHs are good. Quick warning here. You may be like, well, I think I'm all good. I'm going to quit and move on to the next one. This method works fine, but just like the last one, remember when you put the 2 in front of the Al2O3, that screwed up your aluminum on the front side that you had already thought you fixed. So it's possible that as you go through and fix things, as I fix this, it might break something over here that I originally thought I had fixed, if that makes sense. So as you go through and slowly start fixing things, once you think you have everything lined up, my advice to you is to go back one last time, do one extra round of checking to make sure it truly is all fixed. So let's go back one more time. 2 aluminum, 2 aluminum. 3 SO4s. I now have 3 SO4s. 3 calcium, 3 calcium, 6 hydroxides. 2 times 3 is 6 hydroxides. So yes, this is actually good. So my coefficients are 1, 3, 2, 3. If you leave it blank, we assume that that's a 1. Just like in math, if you have x, it's assumed to be 1x without actually needing to write the 1. So we never actually write 1s in front of these. If you want to, that's fine. I will accept it. But as you move on in chemistry, you will eventually have to get used to not using 1s there. Okay, for this one, split it. Let's follow the method here. Let's just look. Lead and lead. Okay, that's definitely not equal. 3 and 1. So I'm going to go over here. 3. Okay, let's look at the potassium. So I got 3 potassiums here, 1 here. So I'm going to put a 3 there. Let's look at the phosphates next. 1 phosphate, because there's no parentheses. So that means there's only 1 of them. This 4 can be deceiving. Does not mean there's 4 of them. If it helps, put parentheses. Always, you just put parentheses around a polyatomic and know that there's no number here, so that means there's only 1. Okay, so if there's 1 phosphate here, there's 2 of them here, I better double this. But you may have noticed that as I went through, I doubled this potassium, so now or doubled this whole compound. So 2 times 3 actually gets me 6 potassium now. Same thing when I put the 3 here, that gets me 6 chlorine. So I have 6 potassium and 6 chlorine. I need to change this from a 3 to a 6, and that's why I use a pencil. Make sure you use a pencil on that. Let's see if I can... I don't know how good this eraser actually works here. There we go. Let's take the time to make it neat. Set a good example here. 6. So now that I think I have it all done, I'm going to go back through and double check. 3 lead, 3 lead. 3 times 2 is 6 chlorine. 6 times 1 is 6. 6 times 1 potassium is 6. 2 times 3 is 6 potassium. Now there's 2 phosphates, because I multiply this 2 over to the phosphate as well. 2 times 1 of them is 2. And then there's 2 over here with this 2. So everything checks out. This is balanced. And again, as you go through, don't worry about making mistakes at first, because you can see I had to go back and fix that. You might as well just try laying some numbers down, see if it works. At first, you're probably going to be a little bit more random about how you lay those numbers down. But as you get into the rhythm of it, as you get used to it, you're going to find patterns, and you're going to start getting more focused and more precise about where and how you place your numbers to do them quicker and more efficiently. So at first, it's going to seem a little bit haphazard going through and stumbling through these, but you will get much more precise and clean at doing them the more you do. It's just a matter of doing the practice and getting it done. And ask for help as always if you need help.